Now let us go over some important observations regarding the binomial expansion that we have seen. So I have written a plus b raised to n expanded as shown here. Now the first observation is that the number of terms in this binomial expansion will be one more than the index n, right? So if you recollect, in a plus b the whole square there will 3 terms, or in a plus b whole raised to 3 we had 4 terms, and so on. So the number of terms is one more than the index n, right? Then going ahead, sum of the powers of a and b in any term of the binomial expansion is always equal to n, that is the index to which the binomial is raised. So here if you see, in the first term the a had index as n and there was no b term, so we can still visualize that as b raised to 0, isn't it? And what is the sum of n and 0? That is equal to n. In case of the second term, a had the index n minus 1 whereas b had the index 1, and if you add these two once again we get n. Similarly, the sum of indices or the powers of a and b in every term will always be equal to n. So this is a very important property. Then going ahead, the coefficients of the individual terms in the binomial expansion are given by nc0, nc1, nc2 and so on up to ncn, and these are called as binomial coefficients. Okay, so the coefficients have a clear structure and they use the combinatorial terms, that is the terms of the form ncr, and they are called as binomial coefficients. Then going to the next one, binomial coefficients equidistant from the ends are equal. So that means the first binomial coefficient is same as the last binomial coefficient, that is nc0 equal to ncn. Then the second binomial coefficient will be equal to the second last binomial coefficient, which you can see it would be ncn minus 1, because the coefficient that comes just before ncn must be ncn minus 1, and that must be equal to nc1, and so on. So the third coefficient will be same as the third last coefficient. Now all of these come from the fact that we have seen quickly in the beginning of this topic that we have a property of ncr to be equal to ncn minus r, and this helps us in discovering this particular structure, that the coefficients are symmetric.